In this example, we would like to evaluate the integral of x square root 2x minus 1. Now, the first and maybe most key observation we can make looking at this is it does have that desired form we're looking for in terms of making a u substitution. So with that in mind, we think, okay, for a u substitution, we want to pick u to be something inside another function. And looking at the integrand, really the only choice we can come up with that's inside another function would be this 2x minus 1 sitting inside the square root. So we'll let u be 2x minus 1, which would tell us that du is 2dx. So let's see our integrand. We need to convert everything in terms of u's. The 2x minus 1 in the square root becomes a u. The dx, well, we can write 1/2 du is dx, so that part is no problem. But what remains is this leftover x. And this is going to be something that occurs frequently. And whenever you make a u substitution, you're converting your integral in terms of all u's. Any leftover x's can be expressed in terms of the substitution itself. And what I mean by that is if we go up to the substitution, u is 2x minus 1. So if we isolate the x here, we would add 1 and divide by 2. X is going to be equal to u plus 1 over 2. And that will allow us to rewrite this remaining x term in terms of u. So this becomes the indefinite integral of u plus 1 over 2 multiplied by the square root u, and then dx is 1/2 du. So 1/2 du. Now, let's just simplify algebraically. We have 1/2 times 1/2, which pulls out front as a 1/4. Inside our integral, if we think about evaluating this indefinite integral, what we would ideally be able to do is get everything in terms of powers of u. Well, square root u is u to the 1/2, and we need to take that and distribute it through the u plus 1. That leaves us with u to the 3/2 plus u to the 1/2. And now what started off as a relatively difficult integral is extremely reasonable for us to evaluate. So anti-differentiating term by term, 2/5 u to the 5/2 plus 2/3 u to the 3/2 plus c. And now our last step is to just go ahead and resubstitute back in. Replace each of these u's with a 2x minus 1. And let's simplify just a smidge algebraically while we're at it. So 1/4 times 2/5 is 1/10. The u becomes a 2x minus 1. Plus, we have 1/4 times 2/3 is 1/6. And then this will be 2x minus 1 to the 3/2 plus c. So once again, just to reiterate, when applying a u substitution, if you have leftover x's that you need to express in terms of u, the thing to do is to go back to that substitution. The substitution gives you the relationship between the variable u and the variable x.